Hello everyone. Today we're going to discuss the Solow model. The Solow model is basically an economic growth model which tries to explain the economic growth in the long run. This model was independently developed by the American economist Robert Solow and the Australian economist Trevor Swan. However, because Solow connected theory with data and discovered a range of important implications, the model is often referred to as the Solow model. In order to understand it, we need to first discuss the assumptions. So let's consider an economy with a unique final good. In this economy, a large number of households are living, and we're assuming that all these households are identical. They're exactly the same. Because all the households are exactly the same, we can choose a representative household, and we can work with that in our model. Next, we're assuming that the household owns labor and capital, and she supplies all her labor and all her capital to firms for production. So basically, we're assuming that the economy is in full employment situation. The household supplies her labor and capital without regards to wage or interest rates. The amount of labor that she supplies for production at time t, we denote that by LT, and the amount of capital that she rents out to firms for production is denoted by KT. For each unit of labor that she sells out to firms for production, and she receives the wage, and we denote that by omega t. For each unit of capital that she rents to firms, she receives the rental rate, and we denote that one by RT. We can think of capital as machines and buildings, and they are durable. We'll talk about the meaning of durability in a moment. So the amount of capital held by the household in each period is given by an equation which is called capital accumulation equation, or the law of motion of capital. And that's simply KT plus 1 equals to 1 minus delta times KT plus IT with delta between 0 and 1. So let's understand this equation. What's KT plus 1? Basically, KT plus 1 is the amount of capital that the household held at time t plus 1. Let's say that t is the current period and t plus 1 is the next period. So in the current period, she will have KT plus 1 amount of capital. In the next period, she will have the non-depreciated part of this capital plus her new investment. So that will be her amount of capital in period t plus 1. This delta here denotes the depreciation rate of capital. So as we say, the household is the owner of capital and labor. She can save 1 unit of final good. It means she can change one unit of final good into 1 unit of capital and rent it out to firms for production. And then the firms use this capital for production in the next period, but another part of that will be left for the household. That is 1 minus delta times KT, this amount. In the next period, she will have this amount plus this investment, new investment. So the capital will accumulate according to this whole equation here, which is KT plus 1 equals to 1 minus delta times KT plus IT, which is investment, and that is equal to the household's saving. We will talk about saving and consumption in a moment. On consumption, the Solow model is assuming that the households are consuming 1 minus S fraction of their income. So if her income is 1, she saves the fraction S and consumes the fraction 1 minus S. Let's say that this representative household's income is $1,500 per month. So she will spend 1,000 and save another 500. Apart from the households, another important unit of economy is firms and what they produce. On the firms, we assume that there are a large number of firms in the economy who are producing the unique final good, and that unique final good is produced under perfect competition, and that all these firms are identical. Because all these firms are exactly the same, we again choose a representative firm, and we work with that in our model. And the production function of this representative firm is this. So basically it is YT, which is the amount of final good produced at time t. Then we have AT, which captures the state of technology at time t. We have KT, which basically it is the amount of capital hired by the firm from the household at time t. And LT is the amount of labor hired from the household by the firm at time t for production. On this production function, we are assuming that it is twice continuously differentiable in KT and LT. Next, we are assuming that the first derivative of the production function with respect to capital is greater than 0, and also the first derivative of the production function with respect to labor is greater than 0. What we are trying to say here with this assumption is that if we add more capital, then the production increases. If we add more labor, then again the production will increase. So it's suggesting that the output increases by adding more capital and more labor. Next, we're assuming that the second derivative of the production function with respect to capital and with respect to labor separately is smaller than 0 or negative. What this one means is that this assumption means is that the production function is the marginal product of capital is decreasing. Also, the marginal product of labor is decreasing. In other words, if we add one more unit of capital or one more unit of labor, that will increase the output, but not as much as the previous unit. So the more capital we add, the output will increase, but less and less. So that's what it says. If we combine the second assumption with the third assumption, then together they imply that our production function is increasing and concave. It's increasing because each unit of capital or each unit of labor that we are adding, that increases our output overall. But each unit of capital or each unit of labor that we are adding, that increases the output, by less and less amount compared to the previous unit. So the marginal product of capital and labor is decreasing. Graphically, we can show it like this. So if this is our production function, this is our capital, and this is our output. The output is increasing, but it is also the slope of that's decreasing. It's getting less steeper and steeper. That means if we denote a higher level of capital by K2 and a lower level of capital by K1, K2 greater than K1 implies that f of K2, or the output, the f of K2 is greater than f of K1. So this means it's increasing. Similarly, we can draw the same thing for labor. So you see that both these graphs are concave and increasing. Further, we are assuming that our production functions hold in other conditions. So what do the in other conditions say? The in other conditions say that when the labor or the capital is very little, when there is very little capital or labor in the economy, then the marginal productivity is very high. However, when there is too much capital or too much labor in the economy, the productivity converges to 0. The marginal productivity of labor or the marginal productivity of capital converges to 0. So these are the in other conditions. The limit of the first derivative of our production function with respect to capital, or with respect to capital here, or with respect to labor here, tends to infinity, tends to positive infinity when capital here or when labor here goes to 0, and they tend to, the productivity or the derivative, the first derivative tends to 0 when capital or labor goes to infinity. And finally, we're assuming that our production function has constant returns to scale. That simply means that if we double our capital and labor, then our output will only double. That will not triple, or that will increase exactly by the amount that we are multiplying labor and capital. If we are multiplying capital and labor by 2, then our output will double. If we are multiplying them by 3, then our output will triple. So we will have the exact amount of increase in our output. So basically, these are all the assumptions that we are making on the households and the firms in the Solow model. And this is the end of the assumptions. In the next video, we will be solving for equilibrium in the Solow model.